Okay guys, now let's progress towards electrophilic substitution in aromatic ethers. Alright, so this is the reaction that we would see. Now this we have already studied, where if we have electron donating group, then ortho, para, ortho gets activated. What do I mean by gets activated? By activated I mean because of electron donating group, electron cloud in ortho and para position is more, so electrophilic substitution would occur in ortho para owing to maximum electron density, or we can say it assists electrophilic substitution owing to plus R plus resonance effect of OR group. Plus R, that is plus resonance effect, means the property of group to donate electron. Alright, R alkyl group we know are one of the best donors, which we have already seen in my earlier videos. So, and oxygen also gives electron. So as a result of which, what happens is, whenever we are dealing with OR group, that becomes one of the best plus R or electron donating group. Alright, now before we get into Friedel-Crafts reaction, would be talking about Friedel-Crafts reaction. Before we get into Friedel-Crafts reaction, which is my next topic, I would like to clarify certain aspects of electrophilic substitution. Now, when we say electrophilic substitution, what we would be studying is electrophilic substitution with acetyl chloride and methyl chloride. Alright, now when we say electrophilic substitution, means these are the reagents. Alright, reagents are electrophiles, that is, they have to have positive charge. Alright, so these reagents have to have positive charge, so it would be electron loving. Alright, so this electrophilic substitution is purely based on the reagents. Since reagents are electrophiles, so we call it as electrophilic reaction. Alright, not otherwise, because these are nucleophilic. So for electrophilic substitution, we require nucleophile and we require electrophile. Nucleophile is one which has excess of electron, as we see here, and electrophile are those which are cations. Alright, so these are the situations. So when such is the situation, then ortho para substitution can occur, or ortho para both, ortho para, all the substitutions can occur. Alright, similarly here also, either ortho substitution or para substitution, or both the substitution would occur. Alright, so having understood this concept of electrophilic substitution, so we need a reagent which would convert this to this. Alright, so we need a reagent which would convert this to this. Alright, let's get into Friedel-Crafts reaction now. Now, Friedel-Crafts reaction, in case of Friedel-Crafts reaction, we have aluminum chloride as our catalyst, which is a Lewis acid. As explained earlier, it has to be very thirsty for electron. Alright, so Lewis acid itself means lacking electron. Alright, so we start with methyl chloride. We would be studying with methyl chloride as well as acetyl chloride. To begin with, we start with methyl chloride. Now methyl chloride is there, and we already know that when we talk in terms of anisole, OCH3 are ortho para active. Alright, so now what happens is, so this already is there. Now methyl chloride which is there, that has to get to format of carb cation. Now aluminum chloride helps in that. So what it does is, this Cl withdraws its shared electron pair, becomes Cl minus and gets transferred to aluminum chloride, forming AlCl4 minus. Thus, carb cation is generated. Now the situation of electrophile and nucleophile is developed. So, the nucleophile would now attack carb cation. Alright, it could be either ortho or would be either para. So let's understand what actually happens. So what we end up with is 4-methoxytoluene, 4-methoxy, that is para, methoxytoluene major, and minor would be 2-methoxytoluene, that is ortho. Alright, so this attack would be minor, this attack would be major, this attack would be minor, and this attack would be major. Alright, okay, now let's understand what happens with acetyl chloride, CH3COCl. Same thing happens in case of acetyl chloride also. Cl is being abstracted by Lewis acid aluminum chloride to form AlCl4. So we get carb cation CH3C double bond O plus. Alright, so situation is there. So we have ortho para, active anisole. So either this can attack or that can attack, or all three can attack together. Now let's see what exactly happens. So when we treat anisole with acetyl chloride in presence of Lewis acid aluminum chloride, we end up again with major of 4-methoxyacetophenone, that is para position, and 2-methoxyacetophenone. Alright, and why 2-methoxyacetophenone, that is ortho. So again here also we find ortho is minor and para is major. Now another interesting thing that I would like to talk about, there are two factors. One is called as electronic factor and another is called as steric factor. Steric factor deals with bulk. Now for example, CH3, three H's are there, so it's spread out. And like if this would have been major, why electronic factor? Because this H and this O then would have had some hydrogen bonding, and that is electronic factor. Alright, so if this would have been major, then electronic factor would have been dominant. But what we are finding is this is major, so it is steric factor, the bulk size. Since this size is big, CH3 spread out, H, so it has gone there. So steric factor, the bulk size, owing to bulk size, it has gone here. So in this reaction, it is the steric factor which is dominant and not the electronic factor. That's why we ended up with major of 4-methoxy, not 2-methoxy. Same is the situation over here. Now here C double bond O CH3, very bulky. So steric factor wise, it is too very huge. Alright, too much of repulsion owing to steric factor. So it goes to para position where there's least steric hindrance. So here also it is the steric factor and not the electronic factor. Now here this is one of the best example where this molecule shows more of electronic attraction, more of attraction owing to hydrogen bonding, because this has C double bond O, so O and H also would have attraction. So here electronic factor also does exist, but still the molecule prefers steric factor. Alright, why? Because of the bulk. So here again steric factor is dominant, owing to which we get this major. Alright.